Hello dear students, in this video we will solve a very important question based on Pythagoras theorem. This question has also been asked several times in CBSE boards. The question is, in an equilateral triangle ABC, D is a point on side BC such that BD equals to 1/3 of BC. So 3 times of BD is equals to BC. We need to prove that 9 times AD square equals to 7 times AB square. Given to us is an equilateral triangle ABC. Let us draw our equilateral triangle in this manner, keeping BC as the base. Since it's an equilateral triangle, so we will have all 3 sides of the triangle equal. AB equals to BC equals to AC. It is also given to us that D is a point on side BC such that BD equals to 1/3 of BC. So we will take point D on side BC like this, a little bit inclined towards point B as BD is 1/3 of BC. So point D should be inclined more towards point B. We need to prove that 9 times of AD square equals to 7 times AB square. AB is one of the sides of the given triangle and line AD will be derived once we join points A and D. Now since we need square of the sides in our proof, that means we need to apply Pythagoras theorem, as Pythagoras theorem relates the sides in terms of their squares. In order to apply Pythagoras theorem, we need perpendicular lines or lines which drops at 90 degree. So for proof, we'll begin with construction and we will draw AE perpendicular to BC. We will also join points A and D as we need AD in the proof. We need to relate square of AD and square of AB in the proof. So that means we need to locate AD and AB inside the right triangles first. AB can be located in right triangle AEB and AD can be located in right triangle AED. The bases of the right triangles are BE and DE, and now let's evaluate them first. As the given triangle ABC was an equilateral triangle and we have constructed perpendicular AE over side BC, and since perpendicular of an equilateral triangle bisects its base, that means base BC will be divided into 2 equal parts or bisects into 2 equal parts. So we will have BE equals to CE equals to half of BC. So the base BE of right triangle AEB is now sorted out. Now the base of the other right triangle is DE. Now let's try to relate it. From the figure we can say that DE is equals to BE minus BD. Now putting the values of BE and BD. BE is half of BC. We have just figured it out right now. Minus BD is given to us as 1/3 of BC. So now DE equals to the LCM of 2 and 3 will be 6. Now the denominator of the first quantity here is 2 and 2 3s is 6. So multiplying with 3, 3 1s are 3 BC minus 3 1s are 3, 3 2s are 6. That means 2 into 1 will be 2, so 2 BC. So DE equals to 3 BC minus 2 BC by 6. 3 minus 2 will be 1. So DE equals to 1 by 6 times BC. We have sorted out the bases now. Here AE is the common perpendicular for both the right triangles. So we will apply Pythagoras theorem in the first right triangle in order to derive an equation for AE square, and then we will substitute the value of AE square in the second right triangle in order to get the result. From the two right triangles, we can start with whichever right triangle we want, right triangle AED or right triangle AEB. So let's start with right triangle AEB, where AB is the hypotenuse. Now, using Pythagoras theorem, we will get BE square plus AE square equals to AB square. Replacing the value of BE as half of BC, we will have half of BC whole square plus AE square equals to AB square, since BE is half of BC. 1 1s are 1, 2 2s are 4, so 1 by 4 BC square plus AE square equals to AB square. Now we will take 1/4 of BC square towards the right. So AE square equals to AB square minus 1 by 4 BC square. Since we don't have any denominator for the first quantity here, for AB square here, let us assign 1 as its denominator. As we need AB in the proof and not BC, so we will now replace BC with AB, as AB and BC are equal, as they are sides of an equilateral triangle. So AE square equals to AB square by 1 minus 1 by 4. In place of BC square, we will write AB square, since AB is equals to BC. Now, the LCM of 1 and 4 will be 4. 1 4 is 4, so multiplying with 4, 4 into AB square, we will get 4 AB square minus 4 and 4. The denominators are same, so we don't need to multiply with anything. So we will have minus 1 AB square. A square equals to 4 minus 1 will be 3, so we will have 3 by 4 AB square as the value of AE square. Let us assign it as equation number 1. Now, this is our equation 1. Now, in right triangle AED, we have AD as the hypotenuse. So, using Pythagoras theorem, we will get DE square plus AE square equals to AD square. Putting the value of DE as 1 by 6 of BC, we will have 1 by 6 BC whole square plus AE square equals to AD square, since DE equals to 1/6 of BC. 1 1s are 1, 6 6 are 36, so 1 by 36 BC square plus, now we will use equation 1 and replace AE square with 3 by 4 AB square equals to AD square. Now LCM of 36 and 4 will be 36, as 4 9s is 36. So for the first quantity, we will write BC square as it is, as it has the same denominator as the LCM. Now 4 9s is 36. That means for the second quantity, we need to multiply with 9. 9 3s is 27. So plus 27 AB square equals to AD square. Again, we will replace BC with AB, as we need AB in the proof. So in place of BC square, we will write AB square plus 27 AB square by 36 equals to AD square, since AB equals to BC, sides of an equilateral triangle. 1 AB square plus 27 AB square will give us 28 AB square by 36 equals to AD square. 28 and 36 Both can be cancelled by 4. Now 4 7s are 28, 4 9s is 36. Taking 9 towards the right hand side, we will have 7ab square equals to 9ad square. Or we can write the same result as 9ad square equals to 7ab square, which is the desired result. So the question is done. Now try to do this question on your own. Thank you and have a nice day.